Hello grade 12s. Today I'm working through some past exam papers to prepare myself for upcoming exams, making sure I'm aware of the type of questions I'm going to get and get used to drawing at the required speed. I am looking at the Loci topic here, and in particular I'm looking at the CAM. Now 2021 is in the era of the new examiner who started in 2018, and in the previous 3 years he had only asked the CAM as the Loci topic. For 2021 he reverted to the old style and old format where a mechanism and a CAM were asked. So here we've got a CAM and the mark allocation is only 25 marks. So you want to try and complete that aspect in 25 minutes. What you want to try and do as well is make sure that you know what to do, the different types of motion that you would get: uniform motion, simple harmonic motion, uniform acceleration and retardation. Those are the three types of motion that you'll get. Understanding that this is only for 25 marks, a certain amount of the work will be done already, will be given. So if I look at the paper, here is the paper, and as you can see they've done quite a lot of work already. They've hatched the camshaft, they've put in the direction of rotation, they've put in the follower, they've done simple harmonic motion, and there you've got the rest of the graph. The graph has been labeled and the scale's been put in. So that's what happens because it can only be for 25 marks. They have to give a lot of information, and hence I would guess that they're going to give you uniform acceleration and retardation as the motion that you're going to have to get right here. Always take a look at your start time and try and make sure that you finish in the allocated time. Because this is only a 25 mark CAM, you'll only have 25 minutes. I'm starting at 2:55. I need to be finished by 3:20. So if we follow the question here, they've asked you to complete the graph of displacement, put in any missing divisions on the CAM profile, draw the CAM profile and show all constructions. So what I might just start with is checking there. They've labeled that at 0. Our direction of rotation is anti-clockwise, so remember that's implying that the CAM profile is turning that way. So the first point going past here would then be on the right hand side. So that's why we label in the opposite direction. So I'm going to put these divisions in. The extra divisions we're going to have to put in will be 15, 45 and 75. Okay, so there are my extra divisions put in there. Something else that is very important that we need to always remember about when we see the roller is that our projection from the displacement graph is to the center of the roller. So once we've plotted and found where the point is on the division, we still need to draw part of this roller. Otherwise, we would be this whole distance inaccurate in our cam profile. So something very important to remember, our projection is to the center of this roller, so each point needs to have a roller then drawn onto it. So let's carry on and complete the displacement graph. It is said this little aspect was given with simple harmonic motion. Now from 90 to 135. So here we've got a half a measurement. It's at rest. Okay, it's to 135. My apologies. It needs to go across. Okay, so there's 135. From 135 to 180 it rises 18. So at 1 okay, that's to the top of this graph. So there it's going to go straight up like that. Now from 180 to 360 it returns to its original position using acceleration and retardation. Now what that means is we've got to look at how many divisions we've got here. So I've got 0, 1, 2, 4, 5, 6 divisions, and I must then have 6 vertical divisions. My middle is 3. Now what will happen is that if I join up the start corner to the end corner, that will give me the center of this and point 3. So we now need to find the other 2 divisions on either side here. So if we check what that height is, the height is 55. Should be 56. Okay, and is that divisible by 6? It's not divisible by 6. So what we need to do is the line division construction. The line division construction means we're going to take any angle. Now I'm going to just put it in here. Okay, I'm going to take out any angle on this side and mark off measurement of 6 equal measurements. Now I'm going to make 100 my distance. Okay, or go up to 100, which means I've marked off 60. So there's 10, 1, 2, 3, 4, 5, 6. What I then do is I line up my last point with the end of the shape. So here is my last point lining up with the end of my shape. Now if you've got an adjustable set square, you can set it at that angle. And now we slide it back to 0.5, 0.4, 0.3, 2, 1. Okay, so there was 0, 1, 2, 4, 5, 6, and we've transferred them here. Now I check for accuracy quickly that this line 3 should match that point there. And what we're going to do is transfer all of these measurements in. So here is the height at 1 onto the middle line at 3. Okay, so if we mark that off, there's 0, the height 2, 3, 4, 5, and 6. We line them up now. 0 and 0 means that's the point there. Next, we take our corner to height level 1, project it where it intersects the vertical, gives me 0.1. From the corner to height level 2, project where it intersects the vertical is 2. 3 and 3 we've got already. Now the retardation side. Here is the corner to gain height level 4. This is vertical line for where it intersects. That is 0.4. From the corner to height level 5. This is your construction. Where it hits the vertical line at 5 gives me my exact point at 5. When we draw this graph in, the middle 3, so 2, 3, and 4 should be on the straight line. Then we go towards our last point and hockey stick into the corner. And there is our completed graph. Okay, so we've done that aspect. We've put in the missing divisions. Now we must do the cam profile from the graph. Okay, and we've done our 2 constructions here, so we've got that. So we're just finishing the profile. So let's project our points across now. So here, remember we're going to project only a couple of points. So there's 15. There's 30. Remember we're always projecting to the vertical. There is 45. Now let's just line these next ones up. So there is 60. I line it up, but I just make a mark there, saving myself time. Here is 75. Line it up, mark it off. 75. Here was 90, and it was at rest until 135. Okay, now I've got those ones. Let's transfer those at the moment just to get started. So here I'm taking that to 15. Okay, so let's draw the arc, I suppose, for a couple of these. 30 we've got because that's the exact point. It's at 30. Here's 45. I'll project to 45. 60. Project to 60. Now 75, I'm just going to transfer the measurement. 90 to 135, so there's 90, 120. I've still got to find 135 here. Okay, I've got up to 135, so my next point is 150. Okay, I'm saving time by just lining it up and transferring it. There is 180. There's 210. $240. 270. 300. 330. Okay, I want to project all of those around. Okay, 150. Let's just check that. Okay, so 150 and 240 are on the same point. Okay, so 240, 150. Okay, 210. Okay, 180. Okay, 270. 300. We are remembering that we now need to draw our follower. So go and set your compass to the diameter of your follower or radius of your follower, and then go and draw your happy faces, sad faces from each point. Let's be positive, these are all happy faces. So what we need to do now is join up all of those points with a tangent to this arc, because we're trying to have a smooth shape as it comes around. Use your flexi curve or French curve and join that up if you've got one. And there we have a completed cam profile. So I think I've completed all the aspects that they've asked from me here. I've completed the displacement graph, plotted my points, Remember that this is a roller, so I need to draw semicircles or arcs here representing the roller and joining up those points at a tangent. I've finished my drawing at 3:10, which means I have got 10 minutes saved, which I can then bank and use in another drawing.